I'm not sure how to derive this. What was that song?
When you're faced with a problem that you cannot solve, and you just want to give up, don't let your pencil fall, 'cause I know just what you need to conquer BC. Derivatives are the answer, just listen, you'll see. BC seems like a different language, derivatives need some explaining. All I really need to understand is when you talk nerdy to me. Talk nerdy to me. Talk nerdy to me. Here is a scary problem. Let's do the chain rule. We'll show you how it is done. You won't be no fool, 'cause I know just what you need to conquer BC. Derivatives are the answer, just listen, you'll see. BC seems like a different language, derivatives need some explaining. All I really need to understand is when you talk nerdy to me. Talk nerdy to me. Talk nerdy to me. Talk nerdy to me. Codes, let's do a problem X. Just a little problem cubed. Looks like we'll need squared. Oh, two chain.
2 chains close to my jeans. Sold out arenas, you can solve my problems. Texas Instruments, Calc on decks. Second trace Calcs, LMX. International E to the X. Every problem solved, I pose a threat. Easy test, what do you expect? I problem so easy, I solved the set. Anyway, every day I'm trying to get to it. Gotta save in my calc on the chain rule. Anyway, every day I'm trying to get to it. Gotta save in my calc on the chain rule.
Thanks, 2 Chains. Now I know how to do this problem.
First, we are just going to rewrite the problem into y equals. Then we are going to use the power rule and bring down the 2 to the front. Then we are going to use the chain rule, can't touch this, and get negative sine x cubed. Finally, we differentiate x cubed to get 3x squared. Then we simplify to get negative 6x squared cosine x cubed sine x cubed.
A Taylor series. What was that song?
When Taylor was on the test, I kept seeing it look at me when I was on that other problem. Do you think it was just there to make me anxious? Because I was totally studying it all night last night, and I don't know if it's a McLaren or not. So what do you think? Did you think that series was hard? How did that problem even get in here? Did you see it? It's so hard, and that sigma is so crappy. Who's that cheater? It's not even summer. Why does Miss Holloway keep on playing happy? Can I go to the bathroom? Can I drink some water? I really need some. But first, let me take a derivative. Can you guys help me take a test? I don't know if I should use root or ratio. I want to be right. How do I justify it? I want it to be correct. How about calculator glitches #deriv? I only got 10 right in the last 5 minutes. Do you think I should take it slow? Let me take another derivative.
Okay, now I can do this Taylor series.
First, we're going to write out the function and plug in x equals 2 to get e to the 4th. Then we take the derivative of e to the 2x and again plug in x equals 2 to get 2e to the 4th. Next, we take the second derivative and plug in 2 to get 4e to the 4th. Finally, we plug in x equals 2 to the third derivative, 8e to the 2x, and get 8e to the 4th. Then we write out the terms using coefficients and add powers of x minus 2 to the coefficients based off their degree, and then divide each term by n factorial.
How do I integrate this?
When you have an integral submarine.
Oh, right, I can use u sub.
First, we're going to rewrite the integral. Then, we are going to set u equal to x cubed, then derive it, so du equals 3x squared dx. We can add a coefficient of 1/3 outside the integral to bring a 3 inside. This allows us to substitute u and get 1/3 the integral of e to the u du. Then we can integrate to get 1/3 e to the u plus c. Substituting back in, this gives us 1/3 e to the x cubed plus c.
Hey Claire, if the perimeter of the black and white is supposed to be 60 centimeters, then what dimensions maximize the area?
Let's do optimization. The area of a rectangle is equal to length times width, so area equals xy. The perimeter is equal to 2 times the length plus 2 times the width, so p equals 2x plus 2y. We can then solve the perimeter formula for y and substitute 30 minus x into the area formula for y, so a equals 30x minus x squared. We then derive the formula for area, so dA dx is equal to 30 minus 2x. We plug in 0 for dA dx to find the extreme of the function, in this case, the maximum. We get x is equal to 15, and then we use that value to solve for y, and we get y is equal to 15 as well. So a 15 by 15 rectangle maximizes the area of the newspaper.
All I do is win, 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 no matter what. Got money on my mind.
Now that I'm done, I think I'll go for a run. How far did I run? First, we can divide the data into 5 intervals. One from 0 to 1 minute, the next from 1 to 2 minutes, 2 to 3 minutes, 3 to 4 minutes, and then 4 to 5 minutes. Then we add up the y coordinates of the endpoints for each interval and multiply the whole thing by 1/2 instead of dividing each one by 2 to find the average. Simplified, this becomes 1/2 times 0.2 plus 0.4 plus 0.6 plus 0.6 plus 0.2, which is then equal to 1. I ran 1 mile in 5 minutes. Wow, I should do track or something.
Hey,
Talk
Ben.
Indian.
We're halfway.
Talk
I don't know what you speak of.
Can I force quit word? Word.
Hashtag, you call me bae. You call me bae. No. That is bad. Beyond 10 o'clock, Claire's brain no longer function.
Okay, go.
Shot caller, 20 play. You got a friend in me. You got a friend in me. When the road looks rough ahead and you're miles and miles from your nice warm bed,